And I'll start recording the class now. So let's get started with the class. So a couple of people just joined. Let me see where they joined. Yes. Okay. Good. So let's go. So the course page for the course is now changed. Used to be Google Sites. Now I'm trying to actually this term we have to restructure a couple of things, including the communication channels. I'll get into that later. But last year it was all on Google Sites. This year it's on GitHub Pages. So the course page should at least be easier to find. It's here. So let's go through the fundamentals. The course is about simultaneous localization and mapping and its practical application. We'll go into more detail what that actually is next class. But basically it's one of the fundamental abilities that we need for more intelligent mobile robots is to be able to navigate through an environment, to map the environment, to figure out where it is in the environment. And that's all sort of put together in the SLAM problem, simultaneous localization and mapping. I like it in particular, not only for its practical applications, but also because it's a very interesting way in which researchers found methods to overcome the computational complexity problem in artificial intelligence. You may be familiar with the fact that AI, for example, trying to play chess, is in theory not such a hard problem, because you could say, oh, I can move whichever 10 moves that I can make. Then my opponent can make, again, 10 moves by themselves to each one that I make. Then I check all the possible moves I can make again. Then my opponent, so on and so forth. Eventually, the game will end in either a win for me or a win for my opponent or a draw. And then I can figure out a path through this search tree that allows me to always make a move that keeps me on the winning side, if that's possible, and draw otherwise. In theory, that would be that the algorithm would work, but the problem is the runtime and memory consumption for this kind of algorithm grows exponentially, grows way too fast. And we've shown that in order to solve that problem, there's really no better algorithm that we found at this time, and many researchers believe that there is no faster algorithm to solve that problem optimally, to solve it exactly. And there's many problems like that. Even very simple problems turn out to have this very bad runtime complexity. For example, bin packing, which is the problem of you have a number of packages, N packages, and they weigh 1 kilogram, one weighs 3 kilograms, the other one weighs 2 kilograms, another one weighs 5 kilograms, so on and so forth. And you have a backpack, and you want to be able to take the maximum weight that your backpack can carry, 50 kilograms. You want to get as close as possible to that weight without being overweight, using the packages that you have. And even that problem requires you to basically go through all possible combinations. And because of that, the runtime also grows exponentially. If n is 10, then this would be a moderately difficult job for a computer nowadays. Will run in, let's say, a minute. But even if you just shift it to 15, then all of a sudden your computer will spend many hours. If you go to 17 packages, then the computer will spend a couple of weeks. And if you go to 20 packages, then it would take hundreds of years. That's a kind of feature of computational explosion of combinatorial algorithms. And the optimal solution, to find the best solution for this kind of problem, we really don't have any better algorithm that than going through trying all the variations of the packages. All algorithms have this very bad behavior that their runtime grows very, very quickly with the size of the input. But in practice, we can solve these kind of problems often almost optimally, very close to optimally, changing our approach. Instead of trying all the possibilities, instead of forcing or focusing on the optimal solution, we introduce randomness into the algorithm. And by doing that, we can come up with algorithms that will find the optimal solution, or a solution that is within 10% of the optimal solution, in much faster runtimes. Several seconds as opposed to many months. And SLAM is a similar algorithm to this kind of approach. For many people have tried it then with games and various optimization problems, but Fox and Troon were sort of the first ones to apply this to robotics, to the robotics domain. And it has proven itself to be extremely powerful and extremely practical and extremely important algorithm for mobile robots, because basically all mobile robots need to be able to navigate. They need to be able to figure out where they are in the world, and they must be able to map the environment around them, and they must be able to find a path through the environment to reach their destination. And the basics behind this SLAM algorithm, the particle filter algorithm, that one is much more generally applicable. So it can also be applied in computer vision or other kind of object detection algorithms and things like that. So that makes it a very nice algorithm to study. It also provides with a broader approach to solving very hard problems in reasonable amount of time. So as far as the assessment of the course is concerned, there will be one assignment worth 20%. There's a 20% midterm test in class about halfway through the term. There's a final project, 20%, and then there's a final exam worth 40%. The lecture slides will be posted on the chat server. At the moment we're using Discord, but most likely we will have to change to Slack or Telegram. I haven't decided yet. before the exams start. I implemented what I thought was a very nice system for dealing with the exams using Discord, but unfortunately Discord changed the rules and the software, so now the way that I did the exams last year is not possible anymore. I found that out while we were running the FIRA robot competition. And so I've been trying to think of ways to overcome that problem and also introduce some more of the chatbot capabilities into the system. So we may have to switch to Telegram or Slack chat messaging platform in the future. The assignments and the projects I will post. Assignment, basically I will tell you what to do. For the project, you must submit a 2-page project proposal, and then you have some freedom, some leeway in what you want to work on for your final project. The sample code lecture slides, it's a very practical class, and I use extensively Google Collaboratory, which allows me to run online both my lecture slides and actual software, actual code that you can play around with. You can change it, you can see what we implemented, how we implemented it, and why we implemented it in a given way. The Jupyter notebooks, you can follow this link. These are all the Jupyter notebooks relevant to simultaneous localization and mapping. Here they're listed as a directory, and the Google Collaboratory is an online environment for running Python programs. It's kind of nice because they give you a TPU, so if you want to run medium scale machine learning projects, you can actually run them on Google server rather than having to set them up on your own server. The online tools, at the moment we're using Discord, so make sure that you subscribe to the right channels. Also, make sure that you check your Discord account at least once per day for announcements and messages regarding the course. The textbook, I don't actually use a textbook. The Google Collaboratory notebooks that I have are based on current state-of-the-art research papers that I may ask you to also read the actual papers. But you don't need to buy a textbook for this particular course. Academic dishonesty. Do not try and pass off anything as your own work that you do not actually write yourself or work on yourself. Before you submit the assignments, you need to fill out an honesty declaration, basically saying if you did use other sources or if you did work together with other students, then that's okay. You just have to let me know in the honesty declaration. Looks like that, just saying that my name, student ID, worked together on this assignment. I was in a group and discussed it with other students, and I certified that the assignment, I implemented the program myself, I ran the tests myself, and I wrote the report myself. The other sources, the external sources that I used, you can then list them all here. So this is, you need to submit that for the assignment and the project. Also, make sure that you're registered in the correct course and that you have all the prerequisites for joining this course. I don't actually enforce anything as that. If you want to audit the course, that's fine too with me. However, if you want to get credit, then you have to make sure that you are actually entitled to take this course. This mainly applies to our external students from Germany. And because of the COVID pandemic or other events that are outside of my control, if there are major disruptions, then I will let you know, and we may have to change the format of the class, or we may have to rearrange assignments or something like that if in particular right now the COVID pandemic becomes worse and we are forced to go into lockdown again. At the moment, my plan is to hold the first 3 weeks as online classes and the following the other weeks then as real classes, in-person classes. So the first 3 weeks will be online, and after that we will have face-to-face classes. Okay, good. So let me just note that current plan. First 3 weeks online, then face-to-face classes. May have to switch. Okay, good. So are there any questions so far? Or comments? Anybody? No? Okay, good. Then today we will do two things. First thing is we will go through and introduce ourselves. So we will do a short introduction. That means from each and every one of you, I want to know your name, your university background, your programming experience, and your IDE setup, and your hobbies, and why you want to take the SLAM course. So these questions I will ask you in a little bit. I just do a short introduction about myself, and then I will ask each and every one of you to introduce yourself in 2 or 3 minutes. 2 or 3 minutes each. Somebody just dropped out already. Check if... the voice channel. Okay, so a little introduction about myself. Let me see, can I move this one there? So about my own background, I received my PhD at the University of Calgary in 1996. My dissertation was an AI planning system called Doolittle that was able to combine multiple strategies when trying to solve a problem, and even working within a particular problem, it was able to switch strategies. I still believe that that is one of the main differences between human thinking, human reasoning, and AI search algorithms or learning algorithms. So if AI researcher thinks that A* is a good algorithm to use on a particular problem, or a heuristic search function is useful, then they will implement this search function and they will try and solve the entire problem within, or many problems within that domain, using that one approach, that one function. If they want to use neural networks, they use neural networks, particular network architecture, for the entire problem. But humans are much more flexible in their reasoning, and they're able to switch between different problem-solving strategies very efficiently. And so that's what I was trying to do for my AI planning system for my PhD. It was a simulated kitchen robot. So it was a robot that was zipping around the kitchen, opening cupboards, picking up cups, putting cups down, turning on the water faucet to fill the cup with water, to bring it to the microwave, so on and so forth. And the problem is that even for a simple dish like, or even a cup of tea with milk and sugar, would require several dozens of steps, and the search complexity, the cost, the runtime of the algorithm would grow exponentially with the number of steps that it takes to achieve a particular goal. And so these algorithms would run very, very slowly. And I was trying to find ways to speed them up by, for example, learning abstraction hierarchies or implementing abstraction hierarchies. Now, abstraction is a very powerful human problem-solving approach. It basically means that we ignore low-level details until they become relevant. So if I want to go and mail a letter, then at the top level, I just decide how I want to get to the post office. So I could walk, or I could ride the bicycle, or I could drive the car. And each one of those choices has many much more lower level details that are important. Like if I want to drive the car, I need to have a key for the car, and I need to know where the car is, and I need to, the car needs to have fuel in the tank, and the battery in the car needs to be charged, and many other factors. But those I can all ignore until I actually realize that driving the car is a feasible option to get to the post office, because once I park, I can figure out a way to walk to the post office. And there again, there's many low-level details, where the traffic lights are, whether they're red or green, where the sidewalks are. But all of those I ignore at the first part of my planning process. So these low-level details I ignore, and that's that particular approach to problem solving is called abstraction. Now, of course, that problem with that is that if I ignore something that's really important, then it may not work. So if I ignore the fact that my car doesn't have tires on it at the moment, then the whole plan will be a failure. And but then I received my PhD. Now, the next thing that happened is that I became a professor at the University of Auckland in New Zealand. And I sort of realized that even though I was proud of the system that I developed, a lot of the things that I implemented in my simulation, because the kitchen robot was only a simulation of a robot, so it was running around the screen, turn out to be very, very difficult. So picking up a cup is actually something that even today will be very hard for a robot to pick up any kind of cup, to detect any kind of cup, and the shape and how to approach it, and if there's anything in the path, any obstacles, that's quite difficult. But in my simulator, that was just a simple single action, boom, and there was never any possibility of the robot failing. If the robot was close enough to the cup, it would be able to pick up the cup. 100% successfully. But to do that with a real robot turned out is going to be much, much harder. So then the question is, the planning system that I wrote ran very well, but maybe it only ran well because the really hard problems I didn't cover or I didn't discuss. So I realized that we needed to have benchmark problems, proper benchmark problems for AI. And I realized that we need to do things in the real world with our real robots if we want to make sure that the AI algorithms that we develop actually are useful, are not based on wishful thinking or castles in the sky. So at that time, I also got interested in robot competitions as benchmark problems for artificial intelligence systems. Myself and many other researchers as well, of course. So then 2002, I joined the University of Manitoba, and I also focused on humanoid robots, which have been my main research area since then. Now, University of Manitoba, you can see the picture is kind of interesting because for a lot of Taiwanese, it's impossible to imagine how cold it is there. If you look at the picture here that shows the main administration building at the University of Manitoba, then you'll see it looks beautiful, right? Nice blue sky, a little bit of snow on the ground, but the temperature on this day would have been minus 30 degrees Celsius. The maximum temperature that we get in Winnipeg is down to minus 40. It's the coldest city with more than 750,000 people. And then 2016, I joined the National Taiwan Normal University Electrical Engineering Department here in Taipei. So some of the robots that we've been working on, we have some small 45 centimeter tall humanoid robots. They are our robot athletes, so they compete in the FIRA all-round competition, which is sort of like the Olympics for humanoid robots. The robots use a camera in order to recognize the world around them, have 2 legs, 2 arms, and a torso and a head. For stability, we use a accelerometer, 3-axis accelerometer and gyroscope that's mounted in the torso of the robot. And they have been competing at robot competitions very successfully. So 2019, we won a 2nd place in the all-round competition for with these robots. And then we also designed some larger robots, 85 centimeter tall, middle-sized robot, uses more elaborate grippers, but other than that, pretty much the same as a small one. So also uses a camera for recognizing the world around it, accelerometers and gyroscopes. This robot also has special kinematics in the knees and the legs in order to reduce the weight of the legs so that we can move faster. It's also been very successful at the FIRA Robot World Cup competition, winning 1st place in the all-round, which is the King's category, the most important competition in the FIRA calendar. And also the IROS Robot Magic Show, where this robot performed various magic tricks. And that's another competition that we are taking part in. We also have a larger humanoid robot, 134 centimeters tall. And that robot was used for playing soccer mainly in the RoboCup competition. And then our largest humanoid robot, Thormang 137, 42 kilograms heavy or weight. So it's quite heavy, uses 2 computers instead of just a single computer. Has, in addition to gyroscopes and accelerometers, also has a LiDAR sensor and a real sense camera and force torque sensors. And that robot, actually I'll show our most recent project a little bit later. Fiera is a robot competition for youth, so under 14, under 19-year-olds, but also for university students, graduate students, and research labs worldwide. We have air category where people are flying drones, fully autonomous drones. All the robots in the Fiera competition are fully autonomous. So we have our humanoid robots as well, Androsot, which is a different type of humanoid robots, and also wheeled robots playing soccer, and the youth category that uses line trackers and two-wheeled robots, differential drive robots, usually playing a variety of games. Skip that. So I'm going to show you some videos of our robots. So for the Fiera competition, it's like a decathlon in human track and field athletics. A single robot has to compete in 10 different events. One of the events is weightlifting. So let's have a look at our team doing the weightlifting. The robot has to start behind the bar. Approach the bar. So there we use the vision. Now plan the motion for the grippers. So we didn't want it to be just a measure of the shoulder strength, shoulder motors. So this is really a balancing problem and a navigation problem. The robot needs to walk with one foot touching the lift line. It has to lift the bar from low to high. And now that greatly changes the center of mass of the robot. So now the center of mass is up high, so the walking gait is much less stable, and the robot needs to adjust for it, adapt to it. There we had a successful run. We also have the sprint. A false start. This is like the 100-meter dash. So robots have to walk forward 3 meters, and then backwards 3 meters. And if they make any mistake, they have to start from the beginning. And we also do basketball. Oh, this is a qualification video for the competition. So we also include archery. Again, walk forward with the weight low, then lift it up. And there's a marathon that usually takes place outdoors, so that makes the vision problem a lot harder. And it's also much longer, 425 meters. The Spartan race. Oops. And here's a project that we did previously. This is actually a multi-agent SLAM problem. So at that time we were using the Bioloid robots with the Nokia mobile phone as the brain mounted on top to give us the camera. And the robots are mapping the environment because as part of the obstacle run. So obstacle run in Fira is sort of like that. Let me show the obstacle run first. I think I had a, no, it's not obstacle run. Fira also includes the obstacle run competition where we have gates, in this case in yellow, walls in blue, and step obstacles. And the robot has to be able to figure out where they are and then find a path towards the target position, towards the goal position. So we actually implemented a particle filter on the mobile phone. So the first robot is off. And now we start the second robot. And now they actually share the map amongst themselves. And on the right hand side is the shared map that the two robots are exchanging with each other. So for this course we want to implement something similar to that. And then they're trying to find a safe path towards the end zone. So therefore, the obstacle run, they also have to walk underneath the obstacle. Now, our most recent project for the Thormang is a very ambitious one. We want the Thormang to be able to drive the Gogoro scooter. So here are our first tests with the humanoid robot on the scooter trying to balance it. And this is one of those cases where we can implement it easily in simulation. So here's a simulation of our scooter. And it can balance, but to do that in practice is a lot harder. In particular, one of the things that we had not sort of thought about and considered was that for the steering that you need to do, you need to be fast enough, right? So it's difficult for the robot to move the steering axis quickly enough. But the other problem that we have, here the robot is playing a Dr. Eureka game, which is also pretty cool. So Dr. Eureka is a logic game where you need to put the balls into correct configuration. Let's see, did it show at the beginning? By pouring them from one tube to the other. If you want to do this fast enough, you need to be able to pour the tubes quickly, and you need to be able to pour multiple balls. So at this point, we're pouring one ball only from the left to the right, but in the meantime, we've been using. We've also had the robot. They gave it the ability to pour 2 balls or 3 balls at the same time. One of the tricky parts for this project was that grabbing the tubes are transparent, so they're very difficult to see in the camera. So we had to look for the balls and then figure out where the tubes are based on where the balls are. And so the configuration that the robot had to make here was purple, purple, red, red, and green, green. Oh no. Maybe I had to do red, red, green, green, blue, blue. Yeah. Okay, well done. And as far as the scooter is concerned, we also made a game. You can play the game yourself, but you can also control it from outside computer system. So here I use a mobile phone to control the scooter, because when you actually try and control it with the keyboard, it's a little bit difficult. Connection and a broadcast server written in Python. So now you can see I can turn the steering wheel off the scooter with my phone, and then I can drive a little bit. I cheated a little bit because I made it very slow so that I have a chance. Failed. So this is a Flutter app running on the phone, 3GS and JavaScript running in the browser, and a Python bridge between UDP broadcast messages and WebSocket. But I think that... So that's just a technical part on how it's implemented. If you want to try the game for yourself, you can get the Taiwanese driver's license. And I think I still have the server running. So this is a little game that we implemented for the social distancing edition this year in August. So WASD, and you also need the turn signals Q and E, because the goal is to pass the Taiwanese driving test for scooter. So if you have a scooter license, you basically have to go through all of this yourself. To make it a little bit more interesting, I added a Taiwanese bear that makes things difficult. So you sort of have to drive away from the bear. You also cannot go too fast. And the balance... Oh! Yeah, now the bear is harassing me. So you can play that yourself. Then you can see if you can pass the test. If you do it correctly, if you do the whole thing correctly, then you can enter your username here. You can take the test. You get a driver's license at the end. So there are the different parts. You cannot drive, the scooter. You have to make sure you don't drop off the scooter. So these are all the sections that you have to do in the Taiwanese driver's test. Okay, good. So that's enough of background information about me. Now I'll go through the list and I'll ask each and every one of you to introduce yourself. As I said, this is what I would like to know: name, university background, so first year masters at NTNU or third year undergraduate, your programming experience and your IDE for programming. So for myself, be Jackie Baltus, PhD at U of Calgary. $30 years plus. Python, C++, Go, or probably the JavaScript. TypeScript were the ones I used in the last year, last 6 months actually, because those I remember. Hobbies, various sports. Trying to learn Chinese, but unsuccessful so far. And my teacher made me. Yeah, that's not a good reason. I would like to say that SLAM is really a very interesting probabilistic algorithm and a practical method to solve combinatorial problems. And that's what I would say for myself. Now I would like to, so now you get know me a little bit better. Oh, IDE. IDE, I usually code in Visual Studio Code at the moment. And Android Studio. Okay, so now I'll go and I'll pick the students from the list, top to bottom, no particular order, and then please open your microphone and introduce yourself based on these criteria. So first, oops. 61022. So student ID 610-75022H, please introduce yourself now. Unmute your microphone.
Okay. Hello, Professor J.T. Tong. My name is Lin Yu Wei. My university background is Tantan University. Programming experience and ID is Python and C++. ID is Visual Studio Code and Rust. Hobbies is playing violin. And why I want to take the same class is because I want to know how the robot, where it is. I'm interested in it. Yes.
Okay, thank you. Very well done.
Thank you.
Okay, next up at 610-750-3H. So 610-750-30H. Please.
Hi.
Hello.
Hi, Professor Jackie. My name is Zhang Dongjie, and my university background is I'm studying in National Taiwan Normal University. My programming experience in IDE is Python and MATLAB and C. My ID is Python. My hobbies is listen to music and watching movies. So why I want to take the SLM course because my girlfriend is working in a robot company. So I want to learn how the robot works. Thank you.
Okay. So which robot company does she work at?
In Hsinchu.
Hsinchu.
It's a robot clean the floor.
Okay. Okay. Interesting. I didn't know we have robot companies in Taiwan like that. Okay, good. I guess that's true love to take the SLAM course just to help your girlfriend. You're a very good boyfriend. Okay, where's my list? Hey. Okay, next up would be 610-750-33H. Also, you can turn on your camera if you want to, if you have one. So next up, yeah, hello.
Okay, I'm a teacher and I graduated from Tantan University and I am studying at NTNU now. I don't have much programming experience, only some in class because my university subject is related to circuits. Or I want to learn Python and English in this class.
Okay, good. And your hobbies?
Hobbies, I like computer. And maybe look on movie.
Okay. Yeah, good. Okay, then next. Let me check. Can I do this? No. 75040H is next.
Hello, Professor.
Hello.
Hi, my name is Lian Xu, and I used to study in Yunzi University as a Bachelor of Electrical Engineer. And I wrote some programs in C++ and MATLAB, like deep learning projects. And I use Visual Studio as my IDE. And I like to play video games and play ping pong ball with my bro on weekends. And the reason why I want to take the course is that I'm working on a project by using Turtlebot 3 and ROS. I want to add some functions to my robot like gmapping and slab. Yes. So that's it.
Okay, thank you.
Okay.
Next up, 610-750-71H.
Hello, Professor.
Hello.
My name is Xinghua Liu, and I graduated from Tankang University. I don't have any programming experience, but now I'm learning about C programming. I use IDE at Visual Studio, and my hobby is jogging, play computer game, and badminton. And sometimes I will take participating in half marathon before COVID-19. Why I want to take this course is because I saw a lot of video just like you just showed to us. And I'm interested to know how to do that, like these videos. That's all. Thank you.
Okay, thank you. Next up, 610-750-74H.
Hello, Professor. My name is Xiaoming Sui, and my university background is Longhua Science and Technology at University. And my program experience and IDE is based on Unity and Visual Basic. And my hobby is surfing the net and trying to learn English. Yeah, why I want to take the STEM of course because I'm interested about robots and and I want to
You want to navigate your robot. Okay, very good. Yeah, thank you. Then next, Alan Trun. Please unmute your microphone and introduce yourself. But I cannot hear you. Try and restart your Discord. Sometimes that fixes audio problems. I will go to the next student. Then you can try and fix it, and otherwise you can post a message with your answers. Okay, you did already. Okay, good. And what are your hobbies? Billiard ball and computer games. Okay, good. So Aven0314, please unmute your microphone and introduce yourself.
Hey, can you hear me, Professor?
Yeah.
Oh, okay. Hi, Professor. Good morning. My name is Huang Wenqing, or you can call me Awen. And my background, I was graduated from the Department of Biomechatronics Engineering, which is in NTNU, and I finished my bachelor degrees there. And I am studying my master's degree in the same department. And now the area I'm devoted to is the UAV.
Yeah.
I can use the ability to use Python and C++, particularly in machine learning and MCU control development. Yes. And my hobby is listening to music, singing, weight training, and watching animation. Did I open my webcam?
I think it's opening now. Now it stopped opening.
Can you see me?
Not yet, no.
Hello?
Hello, I can hear you, but I cannot see you.
I just keep going.
Okay, yeah.
The reason I take this course is I'll be doing research on UAV path planning area. So I think it will be great to have a knowledge of localization and mapping. And that'll be all.
Okay, yeah, thank you. Then next. Hello? Yeah, thank you. Then next would be Carolina. Hello?
Hey, hello.
Hello.
So, my name is Carolina, and my university background right now I am doing my PhD at NTNU, and Professor Jack is my advisor as well. And about my programming experience, and I've been working with Python for like some years, and I also sometimes use Visual Studio Code. And okay, I haven't tried C++ and Java, TypeScript, but not that much. I mean, I didn't spend like a lot of time on that, working on that. And my hobbies, I like to dance, I like to meet my friends, and I like hanging out with my friends. I like to watch some series sometimes. Sometimes Professor Jack as well invite us to do like some hiking. And yeah, sometimes some sports. Why I want to take this course? So I want to take this course because probably it can help my research. So yeah, I think it would be like really useful for me.
Okay, thank you. Next up, Fu Howard, 1999-0513.
Hello, Professor.
Hello.
Can you hear me?
Yeah.
Okay. My name is Howard Fu. and I study in NTNU, and I major in mechanical engineering. And I know how to use Python and C++. And my hobby is playing volleyball with my friends. And lastly, why I want to take this course? Because I plan to study in robotics next year. And I want to learn some knowledge related to the robotics area. And yes, thank you.
Okay, thank you very much. Next up, Ho Chi Lun.
Hello, Professor.
Hello, I can hear you.
Okay. Hello, everyone. My name is Ho Chi Lun. Yeah, you can call me Julian. And I was studying in National Central University. I was majoring in chemistry, but I don't like this subject, so I changed my career, electrical engineering in NTNU. Yeah. My hobby is recently my hobby is watching politics talking show, because I find that the politician in Taiwan is basically a soap opera every day, so it's addictive. So, and I watch every day. Yeah. While I was eating. Yeah. And I learned C++ and Python about 1 year, and basically I was developing on the Visual Studio. Yeah, I think the Visual Studio is efficient for me. Sufficient for me. Yeah. And why I'm gonna take this class is because we have our lab has a project about pen tracking prediction. Yeah, we are developing an algorithm to implement on an electronic paper device to improve its response time. While during you are using the pen writing on the electronic paper. Yeah, and I think that this is a probabilistic problem, and so the name will be very helpful for my research, for this side project for me. Yeah.
Okay. Yeah. Interesting topic. I like to use the ebook readers, so I think they're very cool technology. Yes. I think mostly I would have assumed that they use Kalman filtering already, though, to do the tracking of the pen.
Yeah, we have implemented a version of Kalman filter, but right now we only can predict the linear path, but not the cursive. You know,
Okay.
when you are writing, you may write some curvature in your pen track, but our algorithm right now can only predict the constant velocity pathway. So it needs to be improved.
Right. Okay. Understand.
Thank you.
Okay. And next up, Jasik.
Yes, can you hear me?
Yeah.
Good morning. I am Jae from Korea. I am now a PhD candidate in the ERC lab at NTNU. I got my master's degree at Korea University related to humanoid robots. They were working with reinforcement learning. nowadays, I am usually using Python and C++ to develop humanoid robot. I like playing basketball and watching NBA. I also like watching videos related to robotics. Jackie is my professor. I had no choice. I had to enter this class. Actually, this is joking. Actually, I already took the SLAM course maybe 3 years ago. I forgot most of them, so I need to learn the SLAM again. SLAM is one of the hottest issues in robotics field, and I want to apply the SLAM and navigation to our humanoid robot. So I would like to take this SLAM course. Okay, thank you.
Okay, thanks. So next up, Jimmy 0824. Hello, I cannot hear you. You are unmuted, but I cannot hear you. Try and reset your Discord. Reboot your Discord.
Sometimes you need to go through the configuration. I don't know, maybe something related to.
I think most of the problems are if you run
you might actually, you might activate the push to speak function accidentally.
Oh, that's true. Yeah. But he's not muted now, so I think that should be okay. Maybe now? No. Okay, good. Now he's muted. So next one would be Kaiwan John.
Hey, can you hear me?
Yes, I can hear you.
Hey, hi, Professor Bells. I'm Kevin. I'm a senior student from Mechanical Engineering in National Taiwan University. And my main interest is robotics and embedded systems. I have done many different robotic projects, either as a course project, robot competition, or research lab, including robotic arm, quadcopter, or autonomous vehicle. And I mostly use Python and C language. I also know a little bit JavaScript and C#. And I don't use IDE very often when developing my project, though I have PyCharm installed on my computer. So I usually use VS Code as the editor and run it at terminal will be enough for this project. I really want to learn the robot operating system because it's new and interesting to me. So I wonder if we will use that package in this course or any other simulation tool. So as for the hobbies, I play volleyball in my spare time. And I really wish to play with Professor since I saw volleyball is one of your sports hobbies in your personal website. Yeah.
Yeah,
and
that
also,
would be fun, yes.
I also trying to learn English unsuccessful as well.
Your English is much better than my Chinese, so.
Thank you. So the reason why I want to take this SLAM course, I have basics of computer vision and AI, but I have not yet dived into the world of SLAM. So hopefully I can learn the application of AI and CV and all the robotic knowledge all put together in this course. So yeah, that's it. Thank you.
Okay, thank you. Next up, Marcelina Lee.
Hello.
Okay, hello. Now I can see your video too. Hello.
Yes. Here I'm Marceline, and I got my bachelor degree at NCKU, National Chengkong University. And I started in architectural design before, and now I'm a first-year master student in NTNU. I'm studying civil engineering. Basically, my research area is computer aided engineering. And my programming experience probably is for half year. And I'm using Python. And for the IDE, I use Visual Studio. And my hobby is I recently played film camera, and I like go hiking, go to the beach. Yeah. And why I want to take this main course is because I'm looking into robotics and automation in construction. So I think it's good to know how to make agent know the environment, like localization and mapping in a building is important to make the robotics and automation in construction more contribution. Yeah, thank you.
Thank you very much. Yes. Yeah, I would think so that localization is very important if you have your robot build the building, because otherwise your walls would be all crooked. It was actually a joke that always at the architecture department at various universities, they always had the strangest buildings. So I remember architecture at the University of Calgary had doors that would open on the third floor, but then there's nothing behind it. So they said, oh, maybe we want to add another part of the building sometime in the future, then we already have the door. But it's always funny that the engineers always had the most problems with the heating and the electricity, and the architects had the most problems with the general outlay of the building. So thank you. And
thank you.
Then next up is Sun. Unmute your microphone and please introduce yourself. Sun, are you there? I cannot hear you. Well, now he's gone.
Can you hear me?
Yeah, now I can hear you.
I changed it to my phone because my PC has some problem.
Okay.
I'm Sun Shen, and my university background. I'm graduate from vehicle engineering before, and I'm interested in the self-driving car. So now I'm enjoying the electric engineering of NTNU now. And my advisor is Jackie Bodies, and we also have projects about the Kokoro, and as you can see before. And my program experiencing have a Python of 1 year and a little bit C, and because of I write Arduino before and try to combine some electrical in the Gogoro. And I use IDE is Visual Studio is a very powerful GUI interface. And my hobby is jogging and go hiking with the professor.
Yes, Sun has been going to almost all our hikes. Yes, very diligent hiker.
Yeah, and try not to die in the mountain. That's why I need to jogging because of I need to increase my endurance.
Yeah, we all try not to die in the mountains. That's our top priority. Yes.
Mm-hmm. And I want to choose this course because of I think SLAM is the most important thing in the self-driving car, and even also in robotic. And I also want to build my own environment in our campus, so that our Gogoro can go around the campus. That is my purpose.
Yep. Mm-hmm. Here you go. Okay. Thank you very much. So that's the end of my list. Did I miss anybody by mistake? Everybody had a chance to introduce themselves. And Jimmy 0824, if you could please post your answers in the text channel. Oh, now I can hear you. Try again. Oh, okay. Yes, now I can hear you. Please go ahead.
My name is Chai Dongling. You can call me Jimmy. I'm graduate with a bachelor degree in electric engineering from Chang'an University. And I have about one year programming experience with Python and a little bit C. I use Arduino and Anaconda and PyCharm.
Mm-hmm.
My hobby is play table tennis and listen to music. And why I want to take the STEM course is I'm just undertaking my senior robotic arm with graphing, and I want to add a mobility platform to use pace training with them. That's all.
Mm-hmm. Okay. Thank you.
Thank you.
Yep. Thank you. I'm glad that worked out. So now, do I have everybody? Everybody had a chance to talk? I think so. Okay, good. Then, right now, let me try and do a poll. So let's try that. I posted a question. I think I'm a good Python programmer. Would you say yes or no? If you say yes, then give it a thumbs up. And if you think no, then give it a thumbs down. Just for my interest. And but it's already clear that the background of the class is fairly wide. So we have some experienced people that have been programming Python for many years and have been using ROS and C++ and robotics. We have some other students that are relatively new to programming. That not necessarily is it's a small disadvantage, but it's not a crucial disadvantage. You can overcome those if you are willing to learn and improve your Python programming ability. If you are brand new to Python, then nope. No. Then I can recommend that you go through the Google Python class. That one is a fairly good short introduction into Python, a short tutorial that gets you going. I will do the similar thing now for the rest of the first class. Now that would be a little bit boring for the other students that have a lot of programming experience already. So let me just try something quickly. Display HTML, no. Yeah, so how can we do this? Okay, good. So I will go through a Python tutorial now, a very short one, to get people started on at least the basics of Python. Now, that would be a little bit boring for people that have done a lot of Python programming already. So I suggest, if you feel competent in your Python programming ability, the 5 people that said yes, you can try and do the exercises in JavaScript instead of Python. That'll give you a different imperative programming language, and it allows you to think back to how you would do things in Python. It's actually very similar to Python and JavaScript. So if you can program in one, you can pretty much program in the other one with learning a couple of syntax changes. Ideologically, the two languages are fairly similar. So let's see where the Python programming cell starts. So I use a Google Collaboratory. You can run it in your own Anaconda or Python environment. If you want to do them in the Google Collaboratory, then you can start with this sheet first. So Python is a programming language developed by Guido von Rossum, who was one of the initial designers and implementers of the Unix operating system in the mid-1980s. Here he is, quite an interesting guy, a very competent programmer, of course. So he started the Python programming language in 1989. It has gained significant popularity amongst programmers, mainly because of its what I consider very nice and readable syntax. And he actually, let me go there. He named it after a British comedy team called Monty Python and the Flying Circus. They are very funny and very famous. And so, as a joke, he named his Python programming language after Monty Python. And he has then extended the language to now, where it is one of the, depending on who you ask, it's either first, second, or third most popular programming language at the moment. Just need to re-render. So if you look at the TIOB index, actually now let me open that one externally. In September, Python now is on in second place. C is still the top programming language, then Java, C++. JavaScript is behind Visual Basic, which is a little bit surprising. Usually JavaScript is one of the top 3 languages as well. So the detailed comparison is not really that important. It's Python is always in the top 3 when people ask programmers. One of the strengths of Python is that it's quite easy to write sort of glue logic and scripting programs. It's a very good scripting language. But it also has a huge ecosystem of various libraries that provide high performance function. So it's the lingua franca of machine learning at the moment. Almost everybody uses Python to develop machine learning models nowadays. And it's also the main language in bioinformatics, so people that are studying protein foldings and things like that, that's all done with the kind of current setup that we have. Python that we use in this course, Python, NumPy, and Matplotlib, which are 2 of the libraries that make Python a lot more powerful. They give you very much a MATLAB kind of environment. Now, at its core, Python is a dynamic multi-paradigm programming language. It is mostly imperative, includes some object-oriented programming paradigms, and also some functional programming components. I missed that here, but those are also important. So now, let's say you're trying to learn Python, or you're trying to learn JavaScript. If you're familiar with Python, then you should do or the same idea and the same thinking using JavaScript. Then how do you start? Well, first you need to install an interpreter or something that will actually allow you to run Python programs so that you can experiment with it. In this case, we use the Anaconda Python distribution. For this course, which you can download from anaconda.com, and you can download the individual edition. It's available for Windows, Mac OS, or Linux. And make sure you download the 3 version, 3.8 in this case. For my machine, it will be 64-bit. If you're running on a Mac, then it would be showing you the Mac OS logo and 64-bit Mac. And if you're doing this under Linux, then you can download the Anaconda distribution for your particular Linux distribution. Now, the reason why we use the Anaconda distribution as opposed to just the Python programming language is that, like I said, there's some very good quality libraries that are not part of the basic language distribution, but they are very important for doing things like for doing scientific computing, like in the SLAM course, and therefore we want to include them as well. To program and install them manually is actually quite cumbersome. Of course, it can be done. If you are dead keen, you could compile everything from source yourself. But that will be a lot of extra work. You need to know exactly which version of which library goes with which other version. And the staff at Continuum.io have done a very good job bundling the different libraries together into one working system, which means that we can use Python, NumPy, scikit, scikit-learn, matplotlib, TensorFlow, PyTorch, all of those libraries very easily. And Colab is sort of nice because I can change the runtime to include a TensorFlow unit, TensorFlow processing unit. So first thing you want to do is install the runtime, in this case install the Anaconda distribution on your computer. Make sure that we use Python version 3, not version 2. Now to edit, different development environments are available. When you install Anaconda, it already comes with idle, which is a very primitive one. Very simple one. Spider, which is quite good, more powerful. It's also included with Anaconda. Now when you install Visual Studio, when you install Anaconda, it asks you if you want to install Visual Studio Code. That's a very popular editor / IDE. You can enable the Python extensions, and it'll give you syntax help and makes your programming much more pleasurable. And PyCharm is a more powerful IDE than Visual Studio Code. It is very, I think it's very nice. PyCharm is developed by JetBrains, the company that makes Android Studio and releases it for free. So Google basically pays for the development of Android Studio. PyCharm is basically Android Studio, but for Python. They have an open source community edition that you can use free of charge. But more interesting, if you have a .edu email domain, email with a .edu domain like ntnu.edu.taiwan, for example, then they provide you with a free educational version. That is actually quite a good deal because it also includes some cloud storage and some continuous integration services for free. So you get several $100s on DigitalOcean, which is nice. So any one of these will work for the course. But you probably want to switch away from idle eventually if we go to the more complex programs. So what I said is that Python is a dynamic programming language. What that means is that types are not checked during compilation. A static programming language is one where every data item has to be typed, and the type has to be known during compilation time. Python and JavaScript both are different in this respect. So I can say I want to declare a variable x, and I want it to have the value 3, then I can just say x is equal to 3. I don't need to specify that x should be an integer. Then I can change x. I can say it's 4.32 plus 1.23. Now x will be reassigned, and the type of x now has also changed, right? It's now not an integer anymore, but a floating point number. Then I can make it a string. Strings and a lot of the Python variables are overloaded. So plus for floating point or integers means normal addition. Plus for strings means concatenation. And Python also includes a complex number data type, which is 1.0 plus 2.3i. But since I in engineering notation, but since I is heavily used in programming, they decided to use j. So this would be a complex number where the real part is 1.0 and the imaginary part is 2.3. And we also have a Boolean data type, true and false, that can be combined using ors, nots, and ands, similar to other programming languages. Actually, let me just change that quickly. If I want to find out the type of a data object in Python, I can simply call the type function. So here I can show that the type changes. That may be of interest to people. To my types. No? Okay, I don't know why it suppresses that message. Never mind. Okay, then like I said, for the dynamic programming language, your types are used. They're not completely thrown away, because every time it actually executes an action, the system needs to know the type of the operands. So if I have a variable x, which is of type string, and a variable y, which is of type integer, then if I try to execute x plus y, then I will get an exception, because the type doesn't know what to do with a string plus a number. Wow. Okay. So if I want this to succeed, then I need to cast y from an integer to a string. So this can be done using the string function. And this is the first part that you need to understand when you're trying to learn any kind of imperative programming language. You need to understand the type system. First of all, what types are available and what advanced data types are available. We'll get to that later on. But you also need to know about the sequencing of the instructions. The sequence. If you look at the program here, then you can see basically every line will be executed one after another. So the sequencing is very intuitive. It's what you're used to from other common programming languages like C and JavaScript. However, not all programming languages are like that. Sometimes the order of execution for a block of statements is not given. It can be up to the compiler or the runtime to decide in which order the statements are executed. For example, in Common Lisp, if you have a if-then-else branch, a cond, then the conditions of the conditional are actually executed in random order. The compiler is free to restructure the code to be able to execute it faster. Or in Occam, another programming language that was popular for transputers in the mid-1990s, there, if you had a block of statements, x is this, y is this, z is something else, those statements would be executed in parallel by the runtime. So basically everything would be run in its own thread as a separate process. That makes it very hard to reason about the program as it executes. Makes it more efficient, but it's harder to write programs for this kind of environment. So luckily Python makes it easy for us. It's one line at a time. X, then Y, then the try, then the print, then the except, so on and so forth. The next thing you need to know is how to create loops in your program, right? Those are one of the cornerstones of imperative programming. They're called more general than just loops. You can call them iterations. It's just a fancy word, basically means the same thing. So you may be the most famous loop that you're familiar with, if you have done a C course or C++ course, then you know, like for I equals 0, I less than 3 I plus plus, you get a loop that iterates 0, 1, 2 for I. That's called a counted loop. In Python, we can do those using, and we must do those using the range operator, because Python doesn't actually have counted loops. It only has loops over sets. In C++, that would be called ranged loops in the latest standard, or looping over collections, the same style that we have for JavaScript. So range is a function that has a start value, an end value that is not included, and an incrementer. So for I in the range from 0 to 12, increment by 3 will mean that I will start at 0, then it'll be 3, then 6, then 9, then 12, but 12 will not be executed. So this particular loop here will print 0369, and then it'll terminate. Now, the other very important thing about Python is that, in contrast to C and C++ and older programming languages, some other programming languages, the white space, the tabs here are actually important. Anytime if you see there's no curly brackets in Python, so we're not using the open curly bracket and close curly bracket to identify scope of loops or statements, or to create blocks of statements. In Python, that's done using colon to open a block, to start a new block. Then the next line must be indented by at least 2 spaces, and then whatever is indented will be executed as well as part of the loop. Now, this is one of the most controversial features of Python. A lot of people don't like it. I actually, so the difference is that in Python, your program needs to look reasonable. It needs to look exactly like this. In C, if I want to make a loop, or an entire C++ program, I can write the entire thing on a single line if I want to. In Python, that's impossible, because the spacing of the statements is important. And I actually think this is a really good thing, because if you get that, because otherwise, if you use curly braces, the problem is that then the compiler uses the braces to identify scope and of statements, whereas the programmer always looks at the indentation. Like, every programmer expects that loops are indented like this. If they're not, if I write something like that without the spaces, then I assume that it's not part of the enclosing block. So if I say for I in range 8, then I actually don't think those 2 should be executed, as I just counting from 0 to 8, then doing nothing, and then setting x to 3. Right? If I have this kind of program, then I would expect that if I look at this just quickly, independently of what I know about Python, I would expect that x starts at 0, and then I run some loop that does something, and then after the loop I set x to x plus 3. So I expect it to run, to be set to 3. And if I have it look like this, then I expect it to go 8 times at 3, so it should be 24. So that's what I expect just looking at the structure. In C++, I can actually get this to come out wrong very easily. So for example, I can write int x for int I is equal to 0, I less than 8, I++, right? That will be the corresponding loop there for C. Then I can say x is equal to x plus 3. So if I have this C program, then what will be the output? Now this program looks exactly the same as the Python program, or very similar, right? The same logic. So you would think that it should also print out 24, but in fact, it will actually generate an output of let's see. Printf should be like this. See if I can run that. Then you can see that program will actually execute, but it'll print out 3, not 24. Right? Now, the latest C compilers, if you turn on all the warnings, it'll at least give you a warning telling you that there's something weird going on. So that makes it actually easy. But if you don't have all the warning turned on, you will actually not get any message from the compiler at all saying that there may be an error. And so why is that? Well, the problem here is this semicolon. That semicolon in C++ and C is actually a statement, and it's a null statement. Now, the syntax for loop is that you have for initial condition, test condition, increment condition in brackets, followed by the next statement. The next statement can be a block of statements if they're introduced with curly brackets. But if I put a semicolon there, then that's also a statement. What's repeated is just the next statement. So the semicolon is the next statement that's repeated. So it says do 8 times do nothing. And I can define a block any point I want in the source code. So then it says open a block, execute x is x plus 3, and close that block. But that block is not linked. It's not the statement following the for loop. So it'll only be executed once. So the compiler looks at the curly brackets and decides one way. The programmer looks at the indentation and sees something completely different. These kind of errors are very, very difficult to debug. It can take you a very long time before you realize what's going on there, because you don't expect this, right? You expect that if the indentation and the brackets match up like that, then you think that the loop should range over the x is x plus 3. That should be part of the loop. Only the compiler sees that it's not part of the loop very easily. So that's the reason for using significant white space in Python. You can indent it by 2 space, anything more than 2 spaces. So some people do 2 spaces, some people do 3, some people do 4, depending on what you prefer. I usually just follow the default of my code editor, and the default for most Python programs is 2 spaces, as we use here. So we have counted loops, for loops that are actually ranged loops. We also have a while loop, so I can go num is equal to 15. While the number is greater than 3, I divide it. I do an integer division by 2, so 15 divided by 2 would be 7.5, integer division 7. And then next one 3, and then 1. Next one 3, so then the loop will terminate. Print out. But the standard form of the loop in Python is in C++. You would have, in JavaScript, it'd be a for each loop. In C++, you could use for each, but the latest standard also provides you with range loops for auto n, standard vector, int, vector will give you every element of that vector. That would be the modern way of doing that in C++. You can do the same thing in Python by defining a list. So brackets are indicating a list of elements, and then the list contains 3 strings, A, B, C. Then for x in A, B, C will set x to be equal to A, then B, then C. So it'll print out A, B, C. On 3 lines. So you see the first loop 0, 3, 6, 9, then it terminates. The second loop number is 7, then number is 3, then it'll terminate. And x will be A, B, C. So that's iteration. The next part that you need to know in JavaScript or Python or any other imperative programming language that you want to use would be conditionals. That's another cornerstone of imperative programming. In Python, that is also done using significant white space, and you basically have an if then else condition, except there's no then. You use the colon in order to indicate that a block of statements should follow, and then it'll execute. So if the value is 9 and I say if value is less than 15, value is greater than 6, then I will print out that this value is between 7 and 14. Else I print out then it's smaller than 7, otherwise I print out that it's larger than 14. So this is just a very simple example of this if then else, and a nested if then else in this case. You can see that there's one special thing about if then else in Python. And that is, if I want to do that for more conditions, then it actually becomes a little bit cumbersome. Because let's say I want to check a game, I want to implement a game, and I need to check if the player wants to move up, down, left, right. Then I can check if the key is up, then I move the player up. Else, now in that block, I have to check if the key is down, then I move the player down. Else, if the key is right, then I move the player right. But you can see these next conditions, they keep being pushed to the right, which is not very nice. Adding indentation like that means that your code gets shifted towards the right all the time. That's not very nice to read. So Python provides, for this kind of scenario, it provides an else-if keyboard. So if your else is followed by another if, you can combine it in this. This will work here on top, right? This part here is not wrong. It's a legal Python program. It will execute correctly. However, it has the disadvantage that everything gets pushed towards the right edge of your screen. It's more idiomatic. It's a better Python program to use the else-if keyword, which allows you to combine the else with the following if without having to increase the indentation of your program. So then I can say if the key is A or A, then I print I want to execute command A. Else if the key is B or B, then I print that I want to execute command B. Similar for C, or else I can say that I don't know what the user wants to do, that it's an unknown command. So in this case, the program would execute command B because I set it to command B here. So these are sequences, iteration, and conditionals, which are the important concept that you need to know how to do in any kind of imperative programming language that you want to learn. And if you have followed along using JavaScript, then you can sort of see that it basically allows you to do the same thing. Now, Python also provides us with some highly efficient and powerful advanced data types. Those are used in lots of Python programs. So first one is lists. So you have to understand how lists work. Lists, because Python is a dynamic programming language, turn out to be a lot more powerful than standard arrays or lists in C or C++. You can do a lot more things with them. So a list is started with square brackets. It's surrounded by square brackets. And then the list of elements, if you want to create a list, separated by comma. So here we have a list which has 1, 2, 3, 4, 5, 6, 4.5. So first elements are all integers. Next element is a floating point number. That would not be legal in C or C++. Then we have 3 strings, Joe, Bob, and Bill. And then I have another list here in itself towards the end. So this entire element is actually a list which includes A, 10, B, 20, C, 30, and then 8 and 9 at the end of the list. To access elements of the list, I can use the square bracket syntax in order to retrieve individual elements. Elements are indexed starting at 0. So list 0 would give me the 0 is the element at position 0 of that list, which would be 1. So this will print out 1. I can print out the length of the list, which gives me the number of elements in the list. Now in this case I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of this is 11, right? 12, 13. So I have 13 elements in my list. So the length of the list is 13. And one other neat thing about Python is that you can use negative indices, which will give you the elements from the end of the list. So in Java or C or C++, if you go array -1, then you either get an access violation if you in Java. If you turn it on in C++, then you also get an access violation if you use the right operator. In C, it would just give you the totally wrong value, a random value that happens to be somewhere in memory there, without any error indication at all. So that's that makes for a lot of bugs that can be exploited by hackers, because that way you can read memory of the running executable. If you can get the program to execute list or array access with some random index. In Python, this is actually allowed. It's legal, and it simply means the end of the list. So list -1 is the end of the list, so this will return our element 9 here. This will return the 9 here. And it's the same as saying list length of the list -1. Those two are identical statements. This is just syntactic sugar in order to make it easier to access elements at the end of the list. Now, when I say list, I here I don't mean a single linked or double linked list like you may be familiar with from computer science programming and data structure courses. Internally, they're actually implemented as growing arrays. They're called lists because we can append things to it. We can insert and remove elements from that list. But so it's a dynamically growing data structure, but the actual implementation underneath is very efficient for common cases such as indexing from the left or from the right, as well as getting the first or the last element can be done in constant time for a Python list. So that can happen very quickly. I can do list -2, which will give me the element previous to the last one. So this will be the 8. And lastly, what we can do is I can use slices. I can generate slices. Now slices are from the start value up to but not including the stop value. So in this case, I want to generate I get a list. The return of that statement will be a list that starts at the third index. So 0, 1, 2, 3. That will be number 4. It includes 3, 4, and 5, but not 6. So this will give me a sublist 4, 5, and 6. Or I can also do the same game backwards, of course. So from -4 to -1 would be -4, -3, -2, but not including -1. So this will give me Bill. then the very long list, and then 8. We also have dictionaries. Dictionaries are like hash tables that you may be familiar with from C, C++, or your computer science data structure course. They allow you very efficient access to key value stores. In Python, dictionaries are indicated using curly brackets. And then we have a key, and then we have a value. So let's say in program, I want to store how much money people owe me. Then I can generate a dictionary saying that Joe owes me $20 and I owe Bob $5. So I set that as a value of -5. And Mary owes me $3 US and $4 Taiwanese dollars. And integer key 234 is a dummy that I don't really use for anything, just here to show that I can do that. So the keys can be different types. They don't all have to be strings. They don't all have to be integers. You can mix them. And also the values don't all have to be the same type. I have here some integers and then a list and then a string as the value associated with the different keys. To get access to the values, you use the square bracket notation with the key. So D of Joe would return 20. D of 234 will return dummy. So that's another very powerful data structure that you can use in order to group your data together. In Python, sometimes we also have tuples. Tuples are quite nice to use, especially for return values from functions. They work exactly the same way as lists, except they are not mutable. So that means you cannot change their value. So here I have a list 1, 2, 3, and if I now execute L0 is 5, then my list will be 5, 2, 3, right? Here I have a tuple with round brackets 1, 2, 3. If I try and execute T0 is equal to 5, I get an access violation. And the list will be unchanged. And lastly, we also have sets. Sets are important or are used if you need to have a data structure where you need to where duplicates don't count, where you want to ignore duplicates. So with the curly brackets, I can define a set that has values 1, 3, 4, 5, 2, 2, 2. And then if I print it out, I get only 1, 2, 3, 4, 5. All the 2's here, every element can only occur 0 or 1 time. So there are no duplicates in sets. So here are some more examples of loops. Tom, Mike, Judy, Martha. I can print out the value. And if I want to do formatted output, one of the things that you may have noticed is every time we do print, we get a new line. If you don't want the new line, you can specify end is equal to the empty string here. So if you want to print something like a table for multiplication. So here we have another while loop example. So we check how long I want to write a loop that will print out the segments where the loop is monotonically increasing. So I check starting at 1, if list of 0 is less than list of 1, then I print out the list of 0 is less than list of 1, and then keep incrementing it. Once that's not true anymore, so once I go from 7 to 12, the loop will terminate, so it'll stop. So I get 4 is less than 5, 5 is less than 6, 6 is less than 7, 7 is less than 12. Sorry, 12 to 3 is where it terminates the loop. So here's another example of a conditional for if then else. And lastly, we need to figure out how to modularize your program. And that's done by defining functions. So I can define a function with a set of parameters. The parameters, again, are not typed. Python uses what's called duck typing, which basically means as long as it executes these statements correctly, it will return a result. It's different from C and C++ and Java, where all the elements must be typed. So I can define a function power xn, and then I return x to the power of n. So, and then I can provide print out the result, power 4, 3. Now, that's okay, then that will work, right? It will generate 64, 4 to the power of 3 is what we would expect. What you may not expect is that this function actually also works for floating point numbers. Okay, that's maybe not so special or so surprising. So this would be the square root of 2.5. Okay. Right? But it'll even work for this. Okay. Star, not star. No, it won't work for this one. Let's change it to multiple, and then it would probably be surprising for you to figure out that you can also multiply ha by 10 times. Okay. And then you get ha 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 ha. So here there's no code that says if type of x is int, or and type of n is int, or anything like that. There's no checks for the type. Duck typing, the principle is based on a Groucho Marx routine, where basically if it walks like a duck and it quacks like a duck, then it's a duck. So for our mult subroutine, if it successfully executes x times n, then it's the right type. And if it doesn't, if it throws an exception, then it's not the right type, and we have to deal with that somehow. Okay, good. So that's the end of the class for today. Next class, we will continue with object-oriented programming and some of the meta-programming features of Python, and also the help function. So until next class, make sure that you have running Anaconda environment and go through the Python examples in this course. Change the default. Okay, good. So let me just finish the class. Oh, and the link to the Python programming worksheet is here. And if you did it in JavaScript, then make sure you can also do it in Python. So bye-bye.
Goodbye, Professor. Thank you.
Thank you, Professor.
Thank you. See you.
Okay, bye-bye.
Thank you, Professor. See you next week.
Okay, see you. Bye-bye.
Thank you, Professor. See you next week.
Okay, bye-bye.
Die Auszählungen gehen voran, Zeit für die nächste Hochrechnung, die jetzt zum ersten Mal einen kleinen Mandatsvorsprung der SPD sieht. CDU und CSU im historischen Tief bei 24,6%, 8 Punkte Verlust. Die SPD legt gut 4 Punkte zu, 25,2%. AfD mit Verlusten 10,8%. Die FDP kann leicht zulegen, 11,6%. Stabilisiert sich jetzt ein bisschen als Nummer 4. Die Linke muss weiter zittern bei 5,0, Grüne 14,3, deutliche Zugewinne, andere Parteien 8,5%. Der neue Bundestag wird der größte aller Zeiten sein. Ein Anwachsen auf rund 730 Sitze ist im Moment unsere aktuelle Schätzung. CDU und CSU kommen auf 153 und 45 Sitze, sind zusammen 198. Die SPD 200, damit wäre sie stärkste Fraktion. AfD 86, FDP 92, Linke 40, Grüne 113. Zum ersten Mal eine Fraktion in einer solchen Größenordnung für die Grünen. Und der Südschleswigsche Wählerverband zieht als nationale Minderheit mit einem Mandat in den Bundestag ein. Verschiedene Koalitionen sind möglich, darüber diskutieren die Spitzenpolitikerinnen und Politiker den ganzen Abend. Vor allem diese beiden Ampelvarianten hätten eine deutliche Mehrheit. Die Jamaika-Variante aus Union, Grünen und FDP, genauso wie die Ampel aus SPD, Grünen und FDP. Allerdings wäre auch eine große Koalition, ja, so kann man sie nennen, auch wenn die Großen mit 25% nicht mehr wirklich groß sind, aus Union und SPD mit einer klaren Mandatsmehrheit. Nicht ausreichen würde es hingegen für ein Bündnis aus SPD, Grünen und Linken. Da würden nach jetzigem Hochrechnungsstand 13 Sitze für eine Mehrheit fehlen. Die Wahlbeteiligung übrigens hat sich praktisch nicht verändert. Unsere Schätzung liegt wie bei der Wahl 2017 bei ungefähr 76%.